Don't forget to like, subscribe and share the videos.
The next topic for the day is Radiothermoelectric Generators. What are these generators? What are its application? Let us understand. Why is it in the news? Recently, ISRO and BARC, Indian Space Research Organization, and BARC, that is Baba Atomic Research Center, has embarked in a joint development. So they have jointly developed this radio thermoelectric generators. What are these radio thermoelectric generators and what is its aim? It is mainly aimed at surpassing the constraints of conventional chemical engines for interplanetary voyages. We are sending many rockets to other planets, so such a mission is called as interplanetary voyages. So when we are involved in interplanetary voyages, then we need sufficient fuel to reach that planet. So the conventional chemical engines has certain drawbacks. What are they? Chemical engines work well for satellite thrusters. They will be working as a good thruster, but then they are inadequate for deep space travel. One thing, it is because of the fuel limitation, because they cannot carry so much of fuel. Already the fuel is the one which occupies the maximum part of the rocket. So they are carrying a lot of fuel. More than that, it is not possible. Other than that, lack of solar power in distant regions. So when there is deep space travel and when they go more away from the sunlight, the sun's exposure, then there will be lack of solar power. They won't be able to harness the solar energy. This is one point. These are the problems related to chemical engine, and as an alternative to these chemical engines, we have this radio thermoelectric generators. So these radio thermoelectric generators have been successfully employed already in US spacecrafts like Voyager, Cassini and then Curiosity, and it has been exceptionally working. So India has also adopted this now. What other things do we have to know? So it will be addressing the challenges in deep space missions, one thing. Next, RTG utilize radioactive materials like plutonium-238 and strontium-90. These are the radioactive materials it will be using. These are just examples, and these radioactive materials will emit heat as they decay over time. Radioactive materials have this capability, their feature or their characteristic is that they will decay over time. So when they decay, they emit heat, and this heat is going to get harnessed. So the heat is harnessed and converted into electricity, and they are going to use couple of components. The first component here is radioisotope heater unit, because to initiate the decay process they must have this radioisotope heater unit, and this is responsible for generating the heat through decay of radioactive materials, and it will initiate the process by releasing thermal energy. So when the thermal energy is released or the heat energy is released, it is then converted into electrical energy. How is it going to get converted into electrical energy? That we'll know. For that, we have another unit or component called RTG unit, that is heat to electricity conversion. How does it happen? The heat generated will be converted into usable electricity, and this conversion takes place through a thermocouple. And what is thermocouple here? This becomes question area. What is a thermocouple? A material that generates voltage when subjected to temperature gradient. What is temperature gradient? When there is difference in temperature, higher temperature and lower temperature. So these materials, when they are subjected to temperature gradient, they will be generating voltages, and these voltages are used to store, charge batteries. So the voltage produced by the thermocouple is utilized to charge batteries, and when the battery is charged, then that charge is used for propulsion. So it is used for propulsion mechanisms, and it will enable interplanetary travel. So what is The advantage of this RTG over the conventional engine. First thing is RTG for space missions. Okay. Independence from solar proximity. Like we saw already, in conventional chemical engines, they use fuels, one thing. Other than that, solar energy is also harnessed. Okay. It means they have to be near to solar energy source, near sun. Okay. They cannot go far away from sun, and deep space exploration will not be possible. But then with RTG, it gains independence from solar proximity. Okay. So unlike solar powered system, RTG operate effectively regardless of the spacecraft's distance from the sun. First thing. Next is, due to this characteristic, it eliminates any constraints related to launch window and planetary alignment. This is also important. Okay. So just because we need to harness this solar energy, what they'll do is they will be having a launch window. In this particular date, in this particular time, if you launch, you can harness more solar energy. Like that, they'll plan and then they will launch vehicles. And then they will also have planetary alignment. Okay, only when the spacecraft is placed at that particular alignment, there will be more harnessing of solar energy. This is what they plan. Okay, but with RTG, all such planning is not required. Okay, because they are independent from solar proximity. Next is reliability and consistency. Yes, they are reliable and consistent. It offers consistent and reliable source of power, which is essential for sustaining prolonged deep space missions, and there will be gradual decay of radioactive materials, which will ensure supply of heat and electricity, because radioactive materials will be released, it will be decayed very slowly, very gradually. So there will be sustained release, and then deep space mission is possible. Okay, so with this we are coming to end of today's session. I hope you enjoyed the session. Let us see in the next session. Thank you.